'Cause I'm in the stars tonight. So watch me bring the fire, set the night light. Shoes on, get up in the morning, cup of milk, let's rock and roll. Kink out, kick the drum, rolling on like a rolling stone. Sing song when I'm walking home, jump up to the top of the brown. Ding dong, call me on my phone, nice tea and I'll get my ping pong. This is dead heavy, can't hear the bass, boom, I'm ready. Life is sweet as honey, yeah, this beach chain like money. This go overload, I'm into that, I'm good to go, I'm diamond, you know I glow up. Hey, so let's go. 'Cause I'm in the stars tonight, so watch me bring the fire, set the night light. Hey, shining through the city with a little funky soul. So I'ma light it up like dynamite. Whoa, bring a friend, join the crowd, whoever wanna come along. Word up, talk, just move right up the wall. They're light, skies are light, so we dance to the breakdown.
Ladies and gentlemen, I got the medicine, so you should keep your eyes on the ball.
This is getting heavy, can you hear the bass? Boom, I'm ready. Levies, sweetest honey, yeah, this bitch sing like money. This go overload, I'm into that, I'm good to go, I'm down, you know I glow. And let's go. 'Cause I'm in the stars tonight, so watch me bring the fire, set the night light. Hey, shining through the city with a little funky soul. So I'ma light it up like dynamite. Whoa, na-na-na-na-na-na-na-na-na-na. Life is dynamite. Na-na-na-na-na-na-na-na-na. Life is dynamite. Shining through the city with a little funky soul. So I'ma light it up like dynamite. Whoa, da-na-na-na-na-na-na-na, eh. Da-na-na-na-na-na-na-na, eh. Da-na-na-na-na-na-na, eh. Light it up, dynamite. Da-na-na-na-na-na-na, eh. Da-na-na-na-na-na-na, eh. Da-na-na-na-na-na-na, eh. Light it up, dynamite. 'Cause I'm in the stars tonight, so watch me bring the fire, set the night alight. Shining through the city with a little fucking soul. So I'ma light it up like dynamite. This is so watch me bring the fire, set the night alight. Shining through the city with a little fucking soul. So I'ma light it up like dynamite.
Hello, grade 5 pupils. This video lesson will cover the week 14 lesson of our mensuration class. Okay, so for this week, you will be able to learn how to find the surface area and volume of a prism and the pyramid, and also how to find the surface area of a cone. Okay, so first, let us learn how to find the surface area and the volume of a prism.
Hey guys, today we're going to learn about the surface area and volume of prisms. Alright, first of all, let's think about a shape. For example, a square. Now, this would be a 2D object. A 3D object, on the other hand, would have another dimension to it. Think of a cube. Now we're going to use this 3D object, this cube, to learn about what surface area means. A surface area measures how much material is required to cover or construct a three-dimensional object. If you imagine for a second that this cube is folded up and that each side is actually paper, then you can unravel this to see the flat 2D paper that would have been needed to create this cube. The area of all of this put together is the surface area. So let's just fold that back up into the form of a cube. Alright, so again, the surface area of the cube would be the area of all of the sides put together. It's pretty easy, right? Great, now let's move on to the idea of volume. Volume measures how much space a 3D object might hold. Just imagine that you fill up this cube with water. The amount of water this cube can hold would be limited to the volume of this cube. Think of it like the maximum amount of space on the inside of the 3D object. Alright, so let's explore the surface area and volume of prisms. Here are two common types of prisms, a triangular prism and a rectangular prism. Notice how the prism starts with a shape and ends with the same shape. Also, notice how if you made a cut at any point of the prism, the inside shape here would be the same as the shape on either ends of the prism. This is one of the key characteristics of a prism. So this, for example, would not be a prism. And why? Because if you cut right here, the middle would be similar in shape, but would be different in size than the two endpoints, thus not satisfying the characteristics of a prism. Okay, so let's first deal with learning how to get the surface area of a triangular prism. Let us identify each part of this triangular prism so we can then refer back to them. These two sides of the prism are called bases, and the sides that are not bases are called lateral faces. So the formula for this is the following. 2 times the area of the base plus, open bracket, perimeter of base times height of lateral face, closing bracket. So these are the dimension for this triangular prism. We can find the area of this triangular base by using the formula for area of a triangle, which was base times height divided by 2. So we plug in the info to get 12 times 8 divided by 2, which equals 48 inches squared. So the area of the base is 48 inches squared. But don't forget that we've got 2 of these bases on the ends of this triangular prism. Thus, we would multiply the area of 48 inches squared by 2. So far, we're at 96 inches squared. Now, what's the perimeter of this triangular base? Well, conveniently enough, we've got the side lengths of the triangular base given right to us. It's 10 plus 10 plus 12. Which equals 32 inches. All we need to do now is to multiply this to the height of the lateral face. Notice how I said the height of the lateral face and not the height of the triangular base. The height of the triangle, or shall I say the base, was used to find the area of the two triangles that cover both ends of the prism. But the area of the rest of the sides will be determined by the perimeter of the triangular base multiplied by the height of the lateral face itself. So we've got 32 inches for the entire perimeter of the base, and we multiply that to 20. And we get 640 inches squared. So in total, we've got 96 inches squared plus 640 inches squared, which gives us 736 inches squared for the area of this triangular prism. Great, now let's find the surface area of a rectangular prism. This should be fairly easy now that we've got experience with the triangular prism already. So again, here's our formula for finding the surface area of a prism. 2 times the area of the base plus open bracket perimeter of base multiplied by height of lateral face closing bracket. To find the area of the base, we simply do length times width for the rectangular base. So we do 3 times 5, which equals 15 centimeters squared. And since we've got 2 of these areas on the prism, we multiply by 2, giving us 30 centimeters squared so far. Good. What's the perimeter of this base shape? Well, the opposite sides are the same in length, which means it's 3 plus 3 plus 5 plus 5, making it 16 centimeters. Since the height of the lateral face here is 6, we do 16 times 6, giving us 96. Finally, we do 30 plus 96 to get 126 centimeters squared as the total surface area of this rectangular prism. Awesome. Now let's take a look at how to find the volume of a prism. Remember that when we're looking for the volume, we're looking for the amount that can actually fit in to the 3D object. The formula for getting the volume of a prism is the following. Area of the base multiplied by height of the prism. For a triangular prism, looking at the one that we are dealing with in the beginning of this video, the area of the base is 48 inches squared. The height of the prism is 20 inches. So if we apply this to our formula for finding the volume of a prism, we would do 48 inches multiplied by 20 inches, giving us 960 inches cubed. Now notice how we denote it as cubed to represent the volume, whereas the area or surface area of something is denoted by writing it as squared. To finish off our lesson, we'll look at how to find the volume of a rectangular prism that we saw earlier on. And again, remember that we got the surface area of this prism before. And now we're looking at the volume. These are 2 completely different things. So again, the formula for volume of a prism is area of base times height of prism. The area of the base for this prism is simply 3 centimeters times 5 centimeters, which is 15 centimeters squared. The height of this prism is 6 centimeters. So all we need to do is multiply 15 by 6, making the volume equal to 90 centimeters cubed. It's pretty easy, right? Well then, I implore you to try some questions so that you can commit this to your memory right away. That's it for this lesson, guys, and I encourage you to take a look at how to find the surface area and volume of pyramids for your next lesson.
Okay, so next we will learn how to find the surface area and volume of the pyramid.
Hey guys, it is now time to learn about how to find the surface area and volume of pyramids. Alright, so we went into detail about what surface area and volume meant in our surface area and volume of prisms video. So we'll assume that you already know this material. Let's go straight into it then. Here is a square-based pyramid. Let us first identify what we call each part of this pyramid so that we can refer back to them. We'll call the bottom of this pyramid the base, and we'll call the rest of the surfaces the lateral faces. So how do you find the surface area of a pyramid? Well, all you need to do is make sure that you find the area of each side and then add it all together. However, do note that this measurement right over here is representing the height of the lateral face and not the height of the pyramid itself. So since this is a square-based pyramid, one of the sides will of course be a square. We can get the area of the base by doing 10 times 10, which equals 100 centimeters squared. Now let's find the area of the triangular lateral faces so that we can add them to the area of the base to get the total surface area. Fortunately, the height of each triangle is given to us as 15 centimeters. Notice how we are dealing with the height of each triangle and not the height of the pyramid itself. Why? Well, we're trying to find the area of a triangle, which should be based on the height of the triangle itself. Since we know the area of a triangle as base times height divided by 2, and we have all the info, we can fill in the formula by doing 10 centimeters times 15 centimeters divided by 2, which equals 75 centimeters squared. And since this pyramid consists of 4 triangles that are identical in area, we can multiply 75 by 4 to get 300 centimeters squared. If we add all the surface areas we've calculated together, we get 300 plus 100 to give us a total surface area of 400 centimeters squared. Now, this was a situation where the height of the triangular lateral faces was given to us, which made it easier to find the surface area of the pyramid. But what if it wasn't given to us and instead we were given the height of the pyramid itself? So let's try another example with different dimensions, but this time given the height of the pyramid instead, and see what we would do to find the surface area here. So in this pyramid, we find the area of the base by doing 8 times 8 to get an area of 64 centimeters squared. And now, let's deal with the area of the lateral faces that we need to add to this. Let's think about this for a second. We know that this here is the height of the pyramid. Since the top of the pyramid is in the dead center of the pyramid, we know that this straight line down would mean the very center of the square on the base side. This means that this over here would measure exactly half of 8 centimeters, making it 4 centimeters. And since the height of the pyramid, which is 7 centimeters, creates a 90-degree angle with the 4 centimeter leg that we just discovered, we can use the Pythagorean theorem to find the value of this right here, which is, of course, the hypotenuse of this triangle. And since the hypotenuse of this triangle is the same as the height of this lateral face, we can use this information to find the area of this lateral face. So all we need to do now is to plug in the information we have at our disposal into the Pythagorean theorem, where a squared plus b squared is equal to c squared. We have 7 centimeters and 4 centimeters as the measurements for our legs that make up this 90-degree angle. So we will plug them into a and b to get 7 squared plus 4 squared equals c squared. If we simplify this, we get 49 plus 16 equals c squared, and thus 65 equals c squared. we know that we can square root both sides and we'd get roughly 8.06 equals c. Therefore, it turns out to be the case that the height of this triangle is roughly 8.06 centimeters. Notice again how this is different from the height of the pyramid. Good. So now that we have the approximate height, let's find the area of this triangle, which we can find by plugging the information we have so far into the formula for finding area of a triangle. This is simply 8 times 8.06 divided by 2, and this works out to be roughly 32.24 centimeters squared. And since there are 4 of these triangular faces, we will multiply 32.24 by 4, which gives us 128.96 centimeters squared. Now, if we retrieve our area of the base that we had calculated earlier on, which was 64 centimeters squared, and add it to our area of the 4 lateral faces, we get 192.96 centimeters squared. So the surface area of this pyramid is roughly 192.96, with some room for error since, let's not forget, we did round that 8.06 earlier on during our calculations. Alright, so it's important to remember that when you are looking for the surface area of a pyramid, and you're trying to find the area of the lateral faces to add to the area of the base, you cannot use the height of the pyramid to find the area of the lateral faces. We need to use the height of the lateral face itself, which will either be given to us or we might have to find it ourselves through some sort of trick. Of course, in this case, we used our knowledge of the Pythagorean theorem to find the height of the lateral face. Awesome! And what about finding the volume of a pyramid? How would we do that? Well, it's pretty easy. All we have to do is follow this formula right here. Base area times height of pyramid divided by 3. So in this situation, we have both the height of the triangular lateral face over here and the height of the pyramid. If the question was asking us to find the surface area, then we would use the height of the lateral face to find it. But if the question was asking us to find the volume instead, we would focus on the height of the pyramid itself. So we can fill in our formula with the information we have at our disposal. For the area of the base, we do 8 times 8, which equals 64. We multiply 64 by 7 and divide by 3 to get an approximate total of 149.33 centimeters cubed. So there's our volume. So again, take a look at the difference between how to find the surface area of a pyramid and how to find the volume of a pyramid. And try some questions so that you can get used to it in no time. So until next time, have a good one.
Okay, so then lastly, we will learn how to find the surface area of a cone.
What's up, guys? In this video, we're learning about how to find the surface area of a cone. Alright, so let's consider an ice cream cone, except without the actual ice cream, of course. So this is what a cone looks like. Its surface wraps around, and the bottom is a circle. And yes, this circle is also part of the surface area of the cone. Alright, so the question you've probably been begging to know the answer for is, how do we find the surface area of a cone? Well, the formula is simple. The surface area of a cone is equal to base area of the cone plus lateral area of the cone. The base area of a cone is simply a circle. The area of a circle, as you might already know by now, is pi r squared, where r is the radius of the circle. The lateral area of a cone is everything else other than the base area. The formula for this is pi rs, where s is the slant height of the cone. Do note that this is different from the actual height of a cone. The slant height will be a little bit longer than the actual height. So if we add these areas together, we get the total surface area. So, without further ado, let's try a question. Well, here we have ourselves a cone. Good. First things first, if we've memorized our surface area of a cone formula, then we can just start by busting that out right here. The slant height, or this S, shall I say, is 7 centimeters. The radius, or the R over here, is 5 centimeters. Good. So if we plug in our values, we've got pi times 5 squared plus pi times 5 times 7. If we simplify, we get pi times 25, or 25 pi, plus pi times 35, or 35 pi. Therefore, 25 pi plus 35 pi equals 60 pi, which is roughly, when we round it to the 10th digit, 188.5 centimeters squared. Great. Let's try another example. All right. Before we move further, we need to see the difference between this question and the previous one. The previous question gave us the values of the radius and slant height. This question, however, gives us the radius and the height of the cone itself. Here is our formula for the surface area of a cone. Now, what can we do about the fact that this S over here is supposed to be plugged in with the value of the slant height and not the height of the cone itself? Should we just plug it in there and hope that magically things happen and that no one notices? No way. That's not what a true nerd would do. Let's take a look at what we've got here. This here is a 90-degree angle. That makes these two the legs of a right-angled triangle, where this slant is the hypotenuse. Now, do you remember the Pythagorean theorem? Well then, let's pull up what we remember. A squared plus B squared equals C squared, where A and B are legs, and C is the hypotenuse. So what we have if we plug our values in is 4 centimeters squared plus 6 centimeters squared equals C squared. Simplified to get 16 plus 36, which equals 52. We have 52 equals C squared, in which we square root both sides to get square root 52 equals C. So the length of the slant is square root 52. So let's write in the square root of 52 here and move on with our formula for finding the surface area of a cone. If we fill in the rest of the variables into the equation here and simplify, we get a result of roughly 140.88 centimeters squared. Not too hard, right? Let's try one more example. Okay, so we want to get the surface area of this right here. But the problem is that if we just get the surface area of an entire cone, then we will have added this amount, which shouldn't be added, and we would not have added this part right here, which should be added. So how would we do this? Alright, let's think this through just so that we're really clear about what our objective is here. We will start by getting the surface area of the entire cone first. Then we will need to subtract this part over here, which is the lateral surface of the small cone. And then we will need to include this part over here into our surface area calculations. This area here can be seen as the base area for the small cone. And as a result, we find out what the surface area of this part is, which was our original objective. So we've effectively created a general formula for ourselves to find the total area of this section here. So how do we find the total surface area of the entire cone? Well, we know that the formula for a cone is pi times r squared plus pi rs. But since we have the dimensions for both the large cone and the small cone, we need to differentiate which one we are talking about. So we will label these r's here with a subscripted L as well as this S, since we want to find the area of the large cone. Now, what's the lateral area of the small cone? Well, the lateral area is just this part right here. And we know that the formula for finding the lateral area is pi rs. But instead of looking at the large radius and large slant height, we should be looking at the small radius and small slant height. So we'll denote these variables with subscripted S for both. Lastly, what's the base area of the small cone? Well, we know it's pi r squared, but we need to be more specific and refer to it as pi times rs squared to represent the small base. That leaves us with this equation here that might look a little bit crazy, but it's really not. And I need to stress this right now. You don't need to memorize any of this. This is just problem solving on the fly and figuring things out. And you'll come to realize how important this is for doing well in university and beyond. Good. Well, let's pull up the dimensions to get a better idea of what we're working with. So we are given the radius for both the large cone and the small cone. Let's plug that in first. If we simplify the squares and rearrange it, we have 25 times pi plus 5 times pi times s large minus 3 times pi times s small plus 9 times pi. Okay, let's figure out the slant heights now. We're given both the height and the radius of the small and large cones. So we can use the Pythagorean theorem to find the slant heights for both of them, starting with the large cone. A squared plus b squared equals c squared. We plug in our values for a and b with 5 and 10 respectively. We get 5 squared plus 10 squared equals c squared. 5 squared is 25 plus 10 squared, which is 100, equals c squared. When we add 25 and 100, we get 125 equals c squared. Let's square root both sides to get square root 125 equals c. So the slant height for the large cone is square root of 125. Now, let's find the slant height for the small cone. So again, a squared plus b squared equals c squared. We plug in our values for a and b with 3 and 4 respectively. We get 9 plus 16 equals c squared. We add 9 and 16 to get 25 equals c squared. Let's square root both sides to get square root 25 equals c. We can simplify this down to 5 since we know that 25 is a perfect square. Good. So now that we have all our values, let's plug these numbers back into the equation that we made for ourselves. Now if we simplify all this by putting it into our calculator, we get a final value of roughly 235.31 centimeters squared as our total surface area for this section. Awesome! The key here is to know that the surface area of a cone is made up of two portions that are added together. We've got the base area, which is the area of a circle. And then we've got everything else wrapping around it, called the lateral area. Once we understand that, we're able to answer questions like the one that we just did. Well, that's it for this lesson on surface area of cones, and we will see you in the next one.
Okay, so that would be all for this week, grade 5 pupils. I hope you have learned something new today. And if you have any questions or clarification, don't hesitate to message me on my messenger account, or you can raise your questions and clarification during our virtual discussion. Keep safe and God bless everyone!